This reaction can be classified as a single replacement or single displacement reaction, where the more reactive halogen is going to replace the less reactive halogen. And the more reactive halogens are higher as you go. So since chlorine is higher on the periodic table than bromine, it will replace it. This can also be classified as a redox reaction, which we'll learn in our next lesson. And then we'll also revisit this reaction when we get to electrochemistry at the end of the year. So let's rewrite the products with bromine displaced by chlorine. A reminder, don't carry subscripts over from the reactants. Use the charges crisscross to find the formula. Now we need to balance this. There's 2 chlorines on the reactant side, only 1 on the product side, so we need a coefficient of 2 in front of sodium chloride. That means we need a coefficient of 2 in front of sodium bromide on the reactant side to balance the sodiums. And this is your balanced molecular equation. Now we'll see in an upcoming lesson that this is not the full truth, because these ionic compounds actually dissociate into their ions in water. But we'll cover that when we get to net ionic equations. So if we've covered net ionic equations, we can rewrite this as an ionic equation with the soluble ionic compounds dissociated into ions. And then we can cross out the spectator ion, which is the sodium, and rewrite what's remaining for the net ionic equation. Not sure if I already mentioned this, but this is also a redox or oxidation-reduction reaction. Chlorine is gaining electrons, therefore it's being reduced to chloride ions, and bromide ions are being oxidized to bromine. Oxidation is the loss of electrons.